Hi, I'm Dr. M. Kamakshaya. I'm open source software evangelist and a full stack developer, academic of data science and analytics. For the past few videos, I've been explaining about MS Excel. In my last video, I explained how to deal with goal-seek tool inside MS Excel, and in this video, I'm going to talk about how to make use of Solver. Okay, so how am I going to explain Solver? I'm going to use a particular concept called linear programming. Linear programming is all about finding a solution for linear problems. So I'm going to make use of a particular example. So in this demonstration, that is about optimizing the profitability of while producing some set of goods. So here in this worksheet, I've got a model scenario. So I need to optimize the production of chappals, shoes and boots using certain set of resources called leather, metal and solvents. So I need to produce 10 units of chappals, 7 units of shoes and 3 units of boots. And the cell E3 has a formula, some product of these two ranges. So here in this range, I need to find out the optimum price required to produce these many units of these products by using certain resource constraints. So I need to use only 9 units of leather for chappal and 10 units of leather for shoes and 6 units of leather for boots and 5, 9, 1 units of metal for chappal, shoes and boots respectively, and 10, 7, so on and so forth. Now I have the same formula in my cells E5 to E7, where so the sum product of these the price for units of resource optimized should be less than or equal to the actual availability of the resources. So in F5 to F7, I have the total amount of resource in hand, and this is the utilized resource. So by utilizing these resources, I should optimize my profit for given units of each of the products in this scenario. So this is actually the formulation of the problem. Now what are we going to do is that we have to predict or find out the price for each of the products. So here these are my changing cells. So cells B2, C2, D2 are going to be the changing cells, and this is maximization of the profit, which is in E3, and this is the total amount of resources that need to be utilized less than or equal to the available resources. And these are the simple conditions where the P1, P2, P3 and these values should be greater than or equal to 0. So that is, I'm not going to use the conditions because every simple LP problem will follow this condition by default. So we don't, if I have some certain values like this, then I need to have I need to formulate the conditions also in my setup. So how are we going to use the solver? That is the discussion for the procedure. So I'm going to talk, the main aim of this video cast is to demonstrate the procedure required to solve this linear programming problem. Now in data, you got this solver. So when you go to the solver, I'm going to reset all. So my objective function, the set objective, is going to be this one, E3, where I have the sum product of the two ranges. The range of number of units required to be produced for a given range of price for each of the. And now by changing these cells, so these cells need to be changed. And now I'm going to input the constraints, and my constraints are these LHS should be less than or equal to the RHS. So I should use the resources less than or equal to the available resources in hand, something like that. Now I'll just add this enough. I don't need conditions here in this particular. Now first I will try to do it with simple LP, because this is a linear programming case. So I have to press this button solve. So for this solution, so I just have to produce tuple. So my simple LP algorithm shows a solution which goes like this. So by merely producing tuple, 10 units of tuple for this constraints, the availability of the resources in hand, we can attain a maximum profit of 10, maybe 10 stands for 10,000 rupees or whatever it is. So one unit of one unit of price, maybe 100 rupees, something like that. So 100 multiplied by 10, which is going to be 10,000 rupees. But that is not what is the aspiring, the expected solution. I want to produce shoes as well as boots, 7 units of shoes and 3 units of boots. That is what is my expectation. So for the solver and solution always depends on the way they input the data. So if you change the data, our solution also, this is what is called sensitivity analysis, which I'm going to talk in my next video. So here, instead of using a simple LP, I'll try to use this time GRG. This is some gradient descent algorithm, generalized list reduced gradient. That is what is the full form of the GRG. And this is a non-linear algorithm. So earlier we used a linear algorithm. Now I am using non-linear algorithm for the same set of constraints. And now if I solve, I have a different solution. So now I'll press OK for time being, and let's go back and see. This is not acceptable solution, but anyway, the solution depends on the way we input the data. So maybe I need to change my constraints and conditions anyway I didn't use for my solution. So there is no, all I want to see is that whether my resources are less than or equal to the available resources. Yes, obviously, but you see, I have 22 units of leather in my hand, maybe kilograms or whatever it is like. That is why I call unit. So instead of calling a kilogram, maybe tons something. So I have 22 units of leather and only 11 units of leather is used, and 17 units of metal, only 7.3 units of this solution, and 10 units of solvents. Yes, all the 10 units were solved. If that is the case, so my price is going to be, instead of 100 rupees, it is going to be 63 rupees. Earlier I said 100 rupees, right? It is now 63 rupees for each chappal. 10 chappals I need to price 63. For 7 shoes I need to price 44. And 3 boots I need to price 18, which is quite unlikely, right? Because the cost of boots will be more than cost of, the price of, maybe cost of boots is must be greater than shoes, and the cost of shoes must be greater than chappal. And so this is outright, maybe for this data, as far as the constraints are concerned, yes, we are good. We are not going beyond the available units of resources, but the prices are concerned, I don't think this is a good solution. Maybe for this firm it might work, okay, but in order to come up with some 10,000 rupees of maybe 10 lakhs, doesn't matter, it's just a simulated solution data. If I change this 10 into, see why it is happening is because you see, for shoes we are using more leather, and for boots we are using less leather, and for shoes we are using more metal. For boots we are using quite less metal compared to the chappal. And for solvents, as far as solvents are concerned, we are using more for chappal, each of 7 units of shoes and 3 units of solvents for boots, which is not a case expected as expected. So because there are certain uncertainties in our inputs, because of that the pricing strategy, the strategy which we requested from the solver is not as expected. So maybe we have to change these the values for given resources. Then we need to redo the whole solution, procedure. Then we might expect maybe I can just change here. I use less number of 10 is okay for me. Here I want to use 16. I don't know what I'm going to use. And here I want 5 is okay, and 9 metal, and here it is going to be 10. And now let me change this in solvents 10. Here I will use 17 and here I will use 20. And now I don't know, I also have to relook into this. Obviously this should be something, digits. It should be 5 and it should be 7, it should be 10 because I have 22, so I have no problem. And here it should be maybe 3. I use 3 here in order to make a bit random. And here I use 10 and here again I use 15 instead of 20. Now let us go for the solution. So how will be the pricing for increased units of resource for each of these products? Now I press save. I think I didn't save this. Okay, fine, no problem. So once again press the solver. Now everything is okay. My the same sort of solve now. So again it has produced at this time. It is quite, not at all acceptable. So it's not acceptable. So only with Chappal I can achieve some 16 lakhs of profit. No, I want to go for the shoes and boots. Okay, let me change this time. Maybe here I use rand between 1 to 5, and this is going to be maybe here rand between maybe I use 2 to 7. Now this is here I use rand between. So I want to increase that is what is my strategy. I need more resources for boots, then shoes, and chappal, then shoes, then chappal, something like that. Now in the third cell I'm going to use 3, 10, something like that. So I'm increasing. Let's see some sort of, okay, fine. So now let's go to the solver this time, and yeah, everything is okay. I don't need to reset or solve. Yeah, so this looks to be, no, this is also not good. Maybe we have to reverse the resources. Okay, fine. So this time it's okay, but see here the thing is my profit maximized to 22,000 or 22 lakhs, whatever it is. So for 10 units of chappal, I need to see every time the solver is suggesting me the more price for chappal and less price for shoes and lesser price to boots. Maybe because I would like to produce 10 units of chappal and it is giving more price to chappal and little lesser to shoes and more less amount of price to boots. Okay, so like this we can change the input values gradually. Maybe next time we need to reverse the constraints and we have to check. So like this we just can go on and on for different solutions. We can change our strategies every time. The strategy tend to change for given the input set of constraints and units of production. Okay, I'll stop my video here. I can just speak on and on by changing the values and making the solution, making the formulation more dynamic rather than deterministic. So I'll stop my video here. Thanks for watching this video. Stay tuned for the new content. Bye bye for now.